Hello, so this is the second part of the podcast, and this is the part where we're actually going to make calculations. Before we do this, I want to go over this slide one more time. Calorimetry is the science of measuring heat, the amount of heat that's released or absorbed during a chemical reaction or due to the transfer of energy because heat tends to travel from hot to cold substances, and when there's two different temperatures, that tends to happen. There's a transfer of heat. Now, Q represents heat, M, the mass of the object that you're measuring, so it's just one object. C is the specific heat, it's just a number that tells you um, how much energy it's going to need in order for the temperature to go up or down. So we talked about water. It requires a lot of energy in order for the temperature to go up by 1 degree Celsius. And because of that, the specific heat will be really high. But if you have a metal, for example, the specific heat is going to be low, meaning that it's not going to require a lot of energy for the temperature to go up by 1 degree Celsius. So C is very important in determining heat because it tells you how easily something will rise or drop in temperature. So how do we calculate this? If I gave you three of these, you should be able to calculate the fourth one, and that's how you end up calculating it. You're gonna have to manipulate these variables depending on the question. So here's an example of a question that I might ask you. So the question says that a 4-gram sample of glass is heated from 274 Kelvin to 314 Kelvin. That's the temperature. Glass has a specific heat of 0.2 joules divided by the grams times the temperature. How much heat is gained during this reaction? So we're looking for heat, and we learned about a brand new formula. The formula is the following. So let me go ahead and write that for you. Let me shrink this a little bit. See if I could move this up. Let's see. Yeah, I could. And I'm gonna move this up a little bit. There you go. Move this a little bit to the right. Technology. My apologies. Okay, here we go. So, get my pen. Write this in blue. Okay, so let me see. This goes on this side. Dun, 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 dun. Come on, pen. Work. Work, 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 work. Work, 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 work. Okay. Here we go. So the formula is Q is equal to MC delta T, right? Okay. So it's saying how much heat is gained. So we're looking for Q. Q is equal to the mass, which is 4 grams, times the specific heat, which is 0.2 joules per gram times Kelvin. And the temperature change, we're going to put it as final, which is 14, minus initial. Okay. And when you calculate this, the kelvins cancel, the grams cancel, and you're left with joules. So when you calculate this, you're going to do 4 times 0.2 times whatever that difference is. So let's go ahead and calculate that. So go ahead and try that on your own and let me know what you get. Okay, go ahead and pause this. And okay, so your answer should have been 32. So go ahead and write that 32. Again, let me get my pen. So Q is equal to 32 joules. Okay, so 32 joules of energy or heat is gained by this glass. Okay, now the next question is the specific heat of copper is 0.4. So the number is low, very low, meaning that it's gonna require a little bit of energy to increase its temperature. How much heat is needed to change the temperature of a 30-gram sample of copper from 20 degrees Celsius to 60 degrees Celsius? So how is this question different from the last one? And the last one we used Kelvin, and this one we use Celsius. So it doesn't matter what temperature you use as long as it's the same as the temperature found in the constant, in the specific heat. So in the specific heat, it says joules, grams, Celsius. So your temperature change should be in Celsius. If this number happened to be in Kelvin, then or Fahrenheit, which we rarely use in America or anywhere in science, this Kelvin, if it were to be in Kelvin, you would have to change these two numbers into Kelvin too. So as long as they're the same, you're fine. So it doesn't matter. This last example, for example, Kelvin, Kelvin, Kelvin. You see Kelvin 3 times, you're fine. You see Celsius 3 times, you're fine. Just plug it into the formula. So here we go. Let's do that. Here is our smart board. We're gonna start. No. How do you start another one? Technology. There we go. Okay. And then our pen. Let's change it to green. Let's change it up. Okay. So our formula is gonna be the same one. Q equals MC delta T. Q is what we're looking for. It says how much heat, so that's Q. Q is equal to the mass of the copper, which is 30 grams. And C is the specific heat, 0.4 joules per gram times degrees Celsius, and the temperature change is 60 minus 20, which is 40 degrees Celsius. When you calculate this, you could cancel the units to see what units you're going to use. Grams cancel with grams, Celsius cancels with Celsius, and you're left with joules. It could be in kilojoules or joules or even calories. So that's why it's important to always include units. It's always important you show your work. In college, your professors will expect you to show your work, because if you don't, even though you did it on your calculator, your professor will think that you were cheating. So it's very important that you actually include your units in high school and in college. So the heat is going to be equal to 480 joules. So 480 joules is needed to change the temperature from 20 to 60 in a copper, a sample of copper. Now let's try the last question. I think that's the last one. Yeah, that's the last one. So this one's a little different. It says determine the specific heat of a material if a 35-gram sample absorbed 96 joules as it was heated from 293 Kelvin to 313 Kelvin. How is this question different than what we did in the past? We're not finding heat. We're finding the specific heat. Very different, okay? So make sure that you read the question carefully. This is a really good question to ask on a final. So we're going to use the formula Q equals mc delta T, and it says determine the specific heat. So we're solving for this. So how do you get that by itself? You're gonna divide m and delta T on both sides. Okay. And your new formula is going to be C is equal to Q over M delta T. And then you start plugging it in. So Q is the heat, and it says that it's 96 joules. And the mass is 35 grams times the temperature change. So if you don't want to get confused, just do the calculations first. So 313 minus 293 would be 20. So do that first for delta T so that way you don't get confused with all the parentheses in your calculator. So 20 Kelvin. And if you don't put your units, you're not going to get the units for the specific heat right. So when you do this, you're going to put 96. Make sure you use your calculator correctly. 96 divided by 35. Hit equals. And then divide one more time by 20. And the specific heat is going to be very low. And it makes sense. Well, it doesn't make sense because we don't know the object. But it's probably a metal. And the specific heat is going to be 0.13 joules per gram times Kelvin. And how do you know the units? Well, they're right here, joules, grams, Kelvin, and that would be the specific heat. Make sure you know how to manipulate the formula, because delta T, if I ever say, oh, here's the specific heat, here's the mass, but here's the initial temperature, what is the final temperature? You need to know that delta T is the temperature final minus initial temperature. So make sure that if I give you everything but this is what you're going to be solving for. So now you're going to be doing a lot of this in the homework. So make sure that you do your homework if you want to understand this in depth. And ask questions. Ask your peers questions. Again, I encourage you to use your peers first and then use your teacher, because you learn better when you use your peers. That is all. Go ahead and start on the calorimetry questions 1 through 5, and hopefully this makes a little bit more sense. You're going to have a quiz on this on Wednesday, so this is going to force you to study tonight, so make sure you do that, okay? All right, I'll see you guys in class on Wednesday.